So qualitative factor that influence solid-state sintering. We are talking about particle size. Generally, smaller particle leads to larger driving force because smaller particle you have a higher initial surface energy, larger driving force. But at the same time, smaller particle has tendency to coarsen. That's one. But also they have a tendency to so-called agglomerate. They attach each other closely, and they may also give you, I should say, loose or non-uniform packing, not uniform packing, non-uniform packing. Okay. Particle size distribution, also very important. Generally, you want narrower particle size distribution. Remember we said for coarsening, the larger particle has a tendency to grow larger, while the smaller particle has a tendency to disappear. If everything is more or less the same, you kind of limit this phenomenon. That's why people still want, if as much as possible, a narrow particle size for sintering. Okay, temperature. Generally, higher temperature increase diffusion, increase mass transport, especially bulk diffusion accelerated with sintering. That's why you want to do things at higher temperature for sintering. Grain density. You want your grain density to be high or low? Generally high. That's why you do not want to add a lot of polymer bundle into your material system, because those bundle are, even after they are burned away, they leave a lot of porosity. You do not want a high volume fraction of bundle. Okay. Ideally, you want bundle-less, but sometimes you have to add it to give you the necessary plastic property to form certain things. Grain density. Okay. That's what we said. And the uniformity of grain body microstructure. More uniform grain body is what you want. More uniform grain body. You want your grain body before sintering to be as uniform as possible. Remember what we said. Sintering will not correct for any structural defects in your grain state. Whatever your grain state has defect will show up in the sintering. And they will only make it even worse. Delamination, all that stuff happen after sintering. Okay, atmosphere, important. Okay, high vapor pressure inhibits. Remember we said the so-called lead zirconate or the BDC5IB, those barium-containing material, the high vapor pressure, quite often without special care, it's very difficult to sinter them, because as you go and say densify, the stuff go away. And where would they go? They go to the location where they have lower vapor pressure, which is quite often far away from your material. That's why you have to compensate, quite often encapsulate those types of stuff, so-called protected sintering. Okay, impurities. Sometimes it helps,